Now, we've discussed in these forums in the past few months, many times, the role that technology will play as we try to find and adopt sustainable, viable and sensible solutions to the COVID-19 challenges. Back in early April, we in ISLE undertook, on behalf of this group, a technology scanning exercise in which we reached out to over 2,500 companies in the water sector supply chain. We invited them to share their ideas, products and suggestions for how they might be able to assist. The results fell broadly into 4 categories: detection, removal, automation and contingency. And you might recall seeing this slide. Off the back of this initial technology outreach, a collaborative project was formed in which 23 utilities from across Europe, Australia, North and Latin America, plus 2 development banks, all came together to fund a more detailed and more focused technology search. Now, that project is due to complete imminently, and subject to approval from the funding members, I hope to share the key findings with you in a future webinar. What I can tell you is that the project has identified 8 technologies for detecting and monitoring, 32 which have a proven ability to remove and deactivate SARS, 29 which will support remote work, and 26 technologies which can help water utilities manage contingency in times of crisis. And this last grouping is all about helping utilities with their communication, staff deployment, and both customer and supply chain management. The project has identified a plethora of new digital solutions from outside the traditional water sector supply chain, from which utilities would benefit beyond the scope of the current pandemic. Now, going forward, we intend to include a short section in each of these webinars where we highlight, a showcase you might call it, a technology which we think is particularly relevant to you, the Water Action Platform members. This week, the company is Oxford Nanopore Technologies. Now, I should first stress that ISLE has no formal link, shares, commercial interest with Oxford Nanopore. We are simply highlighting them here because we think they're rather special. Now, Oxford Nanopore was formed in 2005, and it's based, perhaps not surprisingly, in Oxford, here in the UK. It does have offices all around the world. And here is Gerard Coyne from Oxford Nanopore explaining what they do.
So the goal of Oxford Nanopore is to develop a ubiquitous method of sensing molecules. Now, this is to enable the analysis of any living thing by any person in any environment. So the technology is currently functionalized for the sequencing of the detecting of DNA or RNA, so RNA or DNA sequencing. Now, the technology has the capability of detecting a wide range of small molecules and proteins, but our commercially available technology is functionalized for this nucleic acid sequencing.
So, as mentioned there, Oxford Nanopore are specialists in nanopore sequencing. What is nanopore sequencing, I hear you ask? Well, according to Oxford Nanopore, it is the only technology that offers direct sequencing of native DNA and RNA and real-time monitoring. So, how does it work? Well, here's Gerard again.
So what we take, as you probably guessed from the company name, we take nanopores. What are nanopores? They're essentially small holes. Protein nanopores, you see them in bacteria. And what we do is we leverage the traits of nanopores and we've embedded them in a membrane that has high electronic resistance. When you apply a potential or a current, you will get a flow of ions moving only through the aperture, as you can see here. You can detect and measure this current, and in this state we call this an open current state, where the ions are passing freely through the nanopore. When you introduce an analyte, as you can see here, in this case represented by a red dot, you can see how there is now a disruption in the flow of current, and you can see this step change here. When you introduce a different analyte, in this case represented by a blue dot, you can see how there is now a characteristic change in the current to reflect that there is now a different analyte present in the nanopore. So simply, nanopore sensing is the detection, measurement and characterization of this disruption in current.
So basically, they can identify the DNA or RNA of microorganisms or viruses in a liquid, be that sewage, water, milk, blood, whatever, by looking at the resistance that is created across a nanomembrane. And different DNA and RNA molecules create different electrical resistances. Now, as many of you know, for the last 10 years, ISLE has run a series of technology forums called technology approval groups. And it's through these tags that we help water utilities identify and adopt new technology. If you want to know more about those, then please contact me separately. But Oxford Nanopore has been active in the water sector for a good few years now, and it was through one of those those technology approval group presentations that I first became aware of them. Indeed, those previous clips have all been taken from their tag presentation. I remember seeing Oxford Nanopore and thinking that it was a great technology, but that it was looking for its killer application, at least in the water sector it was. It's used for loads of important stuff outside of water. Now, clearly, with the ongoing discussions around monitoring of SARS-CoV-2 RNA in wastewater and the potential that this offers as an early detection system, that killer application might now be with us. Now, if you want to know anything more, please visit the Oxford Nanopore website or contact Gerard Coyne, the nice young man on the videos, or indeed click on the link that will be included with this slide deck that will take you to that tag presentation, and you'll see in full detail his presentation. Failing that, you can drop me an email and I will make a connection directly for you.